All right, this is a kind of mini lesson on, I believe it is 3.4 slopes. It's not really part of the standard form information with the intercepts. Okay, so in 3.4 and especially this section, there's kind of different little mini lessons. Like the first part was graphing in standard form with all of the intercepts. Then we had horizontal and vertical lines. And then this is kind of like the third part with slopes. So here we go. Let's talk about slopes. So kind of think of skiing. So when we're skiing, we're going down slopes, okay? Most people want to ski down a slope that is, pretty steep. And that's what slope measures. It measures the steepness of a line or a hill. So slopes that are going down, they are negative. Slopes that are going up, like when you're on the ski lift and going uphill, that's going to be positive. And then as we were talking about today, we were talking about horizontal. Well, those are slopes that are zero. It's a flat line. We have vertical. That's like skiing off a cliff. That is undefined. So here, okay, we have slope is the measure of the steepness of a line, and slope can be described as a constant rate of increase or decrease. And then we have the formula for slope right down here. It's the change in y over the change in x. So in order to find slope, we need 2 points. We're going to label them x1, y1, and x2, y2. Okay? And then we write our formula, which is m equals y2 minus y1 over x2 minus x1. And then we will solve or simplify to get our slope. So as I said, we have 4 different types of slope. We have a positive slope that is described as a uphill. All right, we're going up. This is positive. And a negative slope falls, it goes down, okay? That's gonna be negative. All right, notice we're going downhill here. A slope of 0, okay, is a flat line, okay? That's gonna be horizontal. And a undefined slope is vertical, and that one's going straight up and down. So those are our 4 types of slope. And there are several different ways to calculate slope. So we will go through the first way up here with given a graph. Okay. And first thing we're going to do is we're going to plot these points. So let's plot -1, -2. So that's right there. Then we're going to plot the point 0, -1. That's right there. Then we're going to plot the point 1, 0. So as we can see, these points are in a line if I were to connect them. So in order to find the slope, we're going to use this formula, slope equals, which is m equals, okay? Let me write that slope in there. Slope equals m, it's a fancy cursive m, which is rise over run, meaning we're going to talk about our x's over our run. So in order to calculate our rise, we're going to talk about how do we get from this point on the left to this point right here. So we go up 1 and to the right 1. So that rise is 1 over 1, which we can simplify to 1. But let's just say, it's kind of like a staircase, okay? Kind of like a staircase. Let's look at this. Let's see the staircase I'm talking about. Let's say, some of us skip stairs when we're going up. All right, we're in a rush, so we skip stairs. What if I was going from this point to this point, and I was skipping this middle stair? Well, my rise would be 2, and my run would be 2. And notice 2 over 2 is 1. So notice, no matter what, we're getting the same slope. The key to slope is we need to reduce it. Make sure it is a reduced fraction. So now it says find another point on the line containing these. So let's go ahead and let's keep that up on the board. And to find another point, well, it's quite simple. I just follow the set of directions. Slope is like a set of directions. Like when you're going through media, somebody tells you, how do you get from the Wawa, all right, on Baltimore Pike to say Apollo Pizza? They're going to say, oh, you're going to go up 2 blocks on, I believe it is Jackson, and then you're going to go left 1 block on State Street. So to get another point on my line, I simply follow the directions. So I'm going to continue with this rise. So let's go with the red rise over the run. So if I'm going from here, I'm going to go up 1 and to the right 1. That's another point on my line. That point is 2, 1. All right, but if we wanted to follow my green directions from here, well, another point on that would be, let's go up 2 and to the right 2. That point right there, that would be the point 3, 2. So I can follow these directions to get more points on the line. So let's use this point 3, 2 as my next point on the line. Now it says B as x blank y blanks. Therefore, the slope of the line containing these points is blank. Well, let's look at this. It was -1, -2, and it was 0, -1, and 1, 0. And we had this set of directions. We had the rise over the run, which was 1 over 1. And they're both positive. And this is where it's getting at. Since it's positive, it's increasing. So as x increases or goes up, y goes up or increases. Therefore, okay, my slope containing these points is positive. All right. Now, it says identify the change in y and the change in x on the graph. We did that. That was my staircase numbers. Now it says use any 2 points on the line and the formula for the slope to verify the slope of this line. So let's use the points -1, -2, and 1, 0. So -1, -2, and the point was 1, 0. So my first step is to label. So I'm going to label x1, y1, x2, y2. And then I'm going to substitute. Okay, so my first step was to label. Second is to write my formula, which is already written for me. Three is to substitute. So y2 is 0, y1 is -2, so I have 0 minus -2. Notice I put it in parentheses over. X2 is 1, and x1 is -1. So again, I'm going to put that -1 in parentheses. Now I substitute. And step number 4 is simplify. So 2 negatives make a positive, so that's going to be 2. And then again, 2 negatives make a positive, that's 2. And again, I need to keep simplifying because 2 over 2 is 1. There we go. Now it says to use 2 different points on the line and write it. Well, So this was the difference that I was doing in counting that staircase and counting my slope on the graph. So let's use the point -1, -2. Then the next one was 0, -1. So again, following those steps, I'm going to label. And now I'm going to write my formula. Well, it's written for me. So let's go to substitute. So I'm going to do -1 minus -2 over 0 minus -1. Now I need to go to simplify. So I'm going to simplify the two negatives to a positive. -1 plus 2 is 1. And again, I have two negatives, so I'm going to make it a positive. So that is also 1, and 1 over 1 is 1. So you can see that those points are on the same line. So let's go over here and let's talk about this. And we have graph the points -2, 3, -1, 1, and 0, -1. So in this case, -2, 3 is right there. -1, 1, well, that's right there. And 0, -1, it's right there. Now, to me, if I'm looking at this, I am noticing that my line is going down. It's going down. So let's do all the work here. We have the rise over the run. So I'm just going to count, how do I get from this point, let's just say to this point, because this is going to give me some, better math to do. Okay, I could go to that point, but I want to go to this bottom point. So I'm going to count down 1, 2, 3, 4. So I went down 4, so my rise is -4. And my run is 1, 2. So -4 over 2 is -2. So now I can start answering these questions. So find another point on the line. Well, let's keep counting down. -4 over 2. It's a set of directions, okay? And if I have a slope of -2, well, I can make it a set of directions by putting a 1 under. And that would tell me I could go down 2, 1, 2, into the right 1. Look at that. That point's on my line. What is it? That point is 1, -3. So as x goes up or increases, okay, so as x gets bigger, y gets smaller, goes down. Therefore, the slope of the line containing these points is negative. Now, it says identify the change. Well, we did that. So let's talk about these points. Well, it's -2, 3, and -1, 1. Let's talk about that first. So -2, 3, and -1, 1. All right, so first step, I'm going to label x1, y1, x2, y2. And then I'm going to go ahead and I'm going to write my formula. Well, it's written for you. So now I'm going to substitute. So I'm going to do 1 minus 3 over -1 minus -2. And now I simplify. Well, I notice these two negatives make a positive. So I have 1 minus 3, that's -2. And then -1 plus 2, that's 1. So my slope is -2. Now, to use the other point, well, -2, 3. And let's talk about the point, I believe it was 0, -1. So let's go ahead and label x1, y1, x2, y2. And we know our equation's written for us, so I'm just going to keep substituting. So I'm going to substitute in -1 minus 3 over 0 minus -2. And I'm careful to make sure I put it in parentheses. So I have 0, all right, minus -2 is going to be a +2, so 0 plus 2 is 2. And -1 minus 3 is -4, so that's going to be -2. So you can see, again, my slopes are the same. All right. And I'm pretty sure you can see where this is going. Now here, It says graph the points 2, 1, and 5, 2. So 2, 1, and 5, 2. Right? All right, now I only have 2 points. 2, 1, 5, 2. So let me count my slope. All right, let's look at this. That's my line, okay? Now I can verify my slope, okay? I like to do this to get from here to here. I go up 1 and to the right 3. So I can see that my slope is going to be 1/3. Let me check that. Well, let's find another point on that line to check it. So let's go up 1 from there. Well, let's go to the right 3. Oh, look at that. That point is on my line. That point is 1, 2, 3, 4, 5, 6, 7, 8, 8, and 1, 2, 3. Oh, what's another point? Well, if I go up 1 and to the right 3, I'm off my graph. Look, up 1 to the right 3. I'm over here. I don't know what that is. So now I got to work backwards. So let's think about it. How do I get to this point? From what point gives me that point? So to work backwards, let's think about it. Well, the opposite of up is down. And the opposite of right is left. So that's why I tell you guys to draw your lines throughout the course of the graph so you can get this. So that point, well, that point is -1, 0. Okay? So I have the point -1, 0. So as x increases, y increases because my slope is positive. So therefore, my slope is positive. So my point was 2, 1, and 5, 2. And the more you do this, the better you're going to get at it. So I label, write my formula, I substitute. So 2 minus 1 over 5 minus 2. 2 minus 1 is 1. Now I'm simplifying. 5 minus 2 is 3. Hey, look at that. Now let's use the 2 points that I found. Those 2 points were -1 and 0, I believe. Okay. And the other one was 8 and 3. Okay. Now it doesn't matter the order I put it in. I just wrote it this way because that was the way I memorized. So x1, y1, x2, y2. So I'm going to go ahead and plug this in. So I have 3 minus 0 over 8 minus -1. 3 minus 0 is 3. 2 negatives make a positive. 8 plus 1 is 9. Hey, look at that. 1/3. Now, it says you try, but you're at home. So we're going to do it together. -2, 5, that's going to be 1, 2, 1, 2, 3, 4, 5. And 0, 5. Ooh, look at that. Well, what the heck do I do here? Well, let's connect those. I can see I have a horizontal line. Let's calculate that slope of rise over run. Rise, well, how do I get from here to here? Didn't go up any. When I ran over 2, 1, 2. 0 over 2 is 0. Find 2 more points on this line. So let's go over from here. Let's go over 2 more points. Well, that's 2, 5. That makes sense because those two have a y value of 5 and it's horizontal, so makes sense. Well, what if I don't want to go over 2? Well, what if I want to go over 1? That's okay. We can go over 1 from there. So we went over 2 from there, 1 from there. Well, look at that. 3, 5. So here is x increases, y remains constant. Therefore, the slope of this line containing these points is 0. There is no slope. It's flat. So point number 1 was negative 2, 5, and point number 2 was 0, 5. So we label x1, y1, x2, y2. And we're going to go ahead and substitute. So we're going to do 5 minus 5 over 0 minus negative 2. 5 minus 5 is 0 over 2. Well, that's 0. So my slope is 0. 2 points we found were 2, 5, and 3, 5. So let's label them. We're going to go ahead and substitute them in. So 5 minus 5 over 3 minus 2. That's 0 over 1, which is 0. So again, you can see we're on the same line there because they appear to be on the same line in the graph and have the same slope. And that brings us to the end of that. All right, good luck. Let me know if you need help.